So we've talked so far about reabsorption, we've talked about filtration as well, these two processes that are used in forming urine. And the last step of the urine formation process is what's known as secretion. So I want to talk with this little video about secretion and how it actually works. This diagram at this point hopefully is starting to really look familiar to you. What we've got here is my super simplified representation of the glomerulus. So here's our afferent arteriole and efferent arteriole. Blood's moving in this direction through it as the arrow indicates. And you guys know at this point as well that that efferent arteriole continues on and it becomes the peritubular capillary. So our glomerulus communicates with our glomerular capsule or Bowman's capsule, this structure that you see right here. And that Bowman's capsule or glomerular capsule is continuous with what's known as the renal tubule, which is adjacent to that peritubular capillary. And that's the structure that we have involved in these steps of forming urine. So we talked about filtration previously, that the blood is this conglomeration of things, and that filtration is happening right here between the glomerulus and the glomerular capsule. And everything that's small enough to fit basically gets pushed out of the blood. So most of the water that's in the blood, most of the sodium ions, a lot of other things as well. And as the blood continues on through the glomerulus, its consistency is going to change. And what we're left with in the blood at that point is mostly just the large things that were too big to be pushed out into the glomerulus. We've got our red blood cells, our white blood cells that are going to stay in the blood. We've got the large proteins represented by these little green squiggles as well. And that's kind of the composition of the blood as it's leaving the efferent arteriole. We've talked about reabsorption. So the fact that just because something was small and it originally got pushed out, that doesn't mean we don't need it. We need the water back. We need the sodium ions back. We need the glucose and the amino acids back. So we have this process that the body goes through where we start reabsorbing, primarily through concentration gradients, most of these substances and getting them back into the blood. But the other part of this is, because when we originally filter, we're just filtering based on size, that we end up with these large things that stay in the blood simply because they were too big to get pushed out. So they weren't able to make their way into the glomerulus and become a part of the filtrate. Instead, they stayed in the blood. But just because something's big doesn't mean it's something that we want floating around in our blood forever. It could be a toxin, it could be a waste product, those kinds of things that we do need to get removed from the blood. And so secretion is kind of the last step in the process of urine formation that allows us to get rid of some of those things that were too large to fit, and they move entirely through an active process from the peritubular capillary into the renal tubule. So they're secreted from the blood into the renal tubule where they're then going to become a part of the urine. So I think a lot of times students have the question, why is urine formation this three-step process? Like first we filter stuff and it's passive, we don't use ATP to do it, but then we need like most of that stuff back, and so we have to reabsorb it. And a lot of the stuff that we needed out, it didn't get taken out, and so now we gotta secrete it, and it's what ends up in the renal tubule after we've gone through these three steps that actually becomes the urine that's released from the body. Here's why, okay? Here's why we go through this three-step process. Filtration is entirely passive. The body doesn't have to use any ATP to do it. If you're small enough to fit, you go. Reabsorption is almost entirely passive. So if you remember from that video, there's just that one step in the transport of sodium where we're actually using the sodium-potassium pumps to move sodium across one of the membranes. But other than that, the movement of the sodium is passive, the movement of the water is passive, the movement of the other things that we're reabsorbing as well is passive. When we get down here to secretion, this is entirely an active process where we're using ATP, we're selectively pumping things out of the blood and into the renal tubule. And believe it or not, the combination of those three things together actually use less energy in the form of ATP, because really it's only secretion that's an active process than we would use if we started with an active process here and we said, oh, hey, there's a glucose molecule, we want to conserve that, we don't want it to go. But oh, there's a water molecule and we're overhydrated, so let's use some ATP to push it out. And hey, you ate some French fries, there's a little bit too much sodium in the blood, let's actively push out that sodium, but not the sodium over here so we can get a balance. That would use much more energy than this three-step process that is done almost entirely passively. So again, some genius engineering, biological evolution that's happening within the kidneys to allow the formation of urine. And that, in a nutshell, is the reason for tubular secretion.